Welcome back to this plenary session in GRA6036. We are working on project 11 and we are about to start exercise B. But before we start, exercise F. But before we start exercise F, we forgot one question on exercise E, and that is we should comment on whether an interaction terms between looks and experience seem necessary based on the two estimated models. So remember that our looks or our good looking variable is a binary indicator. So we basically, by using that variable when we estimate the model on the full data set, we are splitting the data in two groups, which we did more manually here by making two data sets for those two groups. So let's look at the output from the model that we fit. So they are here. So the question is whether experience, the effect of experience on log wage seem different for the two groups. Now the first thing to notice is that this coefficient and this coefficient are rather similar or not that different from this coefficient and this coefficient. So it might be okay without an interaction term when we fit a model to the full data set, but at the same time we see that they are both, all four of them are highly significant. So there might be there is indication in the data that there is some difference in the effect of experience in the good looking and the not so good looking group. So that's what we are to investigate more closely here in F. So we are to fit this big regression model to the whole data set. So that's what we called BTY in the script. And so let's call that fit F. So to remember that it's exercise F, when we do BTY log wage, then it's BTY GL, and then it's BTY, so plus BTY expr plus BTY expr squared. So now we need this I function, so square it, plus BTY GL times BTY expr plus interaction with the squared term. So this, and now we fit this model and we can have a look at it using the summary function. So here we are, and now we see sort of what we saw in the last two regression model outputs, is that, well, the effect of the interaction terms here are they are significant at the 5% level, but there are so there is some difference, or in this data it seems to be some difference in the effect of experience in the two groups. So, but had we chosen a lower significance level, for example 1% instead of 5%, we would not reach the same conclusion. So this is based on what significance level you choose to work at. And we are also to assess the individual statistics in beta 4 and beta 5, which is what we already done. So they are significant at so this is, well, beta 4, beta 5 is this one and this one. So those are the interaction terms. So it's these two, both significant at the 5% level. Okay. So now we are to show that the predictions of the model we just fitted, so this model, is the same as those in task E. So one way to show that the predictions are the same is to add new lines to these plots. So the fitted lines based on this model, and then hopefully the fit lines from this model with overlay the lines from this model. So what I mean is that, okay, so if you have a look at this, here's the fitted line, and our new fitted line is supposed to lie, well, overlap this one, and the same here. So let's do that. Lines UU is then fit F QF, and so the interaction term must be included. And remember that this is the good-looking group. So now GL in this model equals 1. So we have fit QF2 times GL, which is 1, plus fit QF3 times 1, 2, 3 expr, which is what we call UU, fit QF4 times UU squared. And now come the interaction terms. So this is fit QF5 times 1, where GL is 1. And now we must pay attention, because if you saw here, see that, so this is 1, 2, 3, 4, 5. This is the one with the square, and this is the one where expr is not squared. So here we should have UU squared, and the last one is then 6 with UU, well, not squared. So let's have this color green, and make the line width 1.6, so we might be able to see the red below it if they overlap. Now we run this code, so we have the red line, and now we add this green line, and we see that the green line overlaps the red line, so the predictions are the same. Now we can do the same thing here, but then we have to pay attention, because now GL is, these are the not so good looking people, so this is 0, then this is 0, and this one is 0. So we add this plot, we get this line, and now we add the green line, and it overlaps. So we see that we see that fitting two models on two different data sets, so the good looking and not so good looking data set, and fitting sort of the same model but with a binary indicator for what data set you belong to, and the interaction terms is the same thing, or gives the same predictions. So that was well, and now suppose that it was claimed that this equivalence always holds. What would it take to convince you that this is true? So well, I wrote a note in lecture 8, I believe. So here, if you have a look at, let's see, so the answer to that question is basically the same as the answer to this question. So have a look at this note if you haven't had a look at it yet. I mean, of course, things are a bit more complicated in project 11 because the regression model is much bigger, but the concepts and the ideas are the same. Also, this is good practice for the exam, understanding what's going on here. Okay, so let's go back to project 11. So we are here. So we've done D, E, F, and now we are done with G. And in the next video, I'll do H and start assignment 2.